Okay, so buckle up, folks. I'm going to talk to you about bugs. It's going to be a little different. We're going to tell you about the MothBox. This is a thing that's basically a big bright light. It attracts cool insects, it photographs them, and then it tries to automatically identify them. And what's even better is you can build it entirely yourself. It's entirely open source. But let me give you a bit of a background on why we are building some sort of bright box that takes photos of bugs. So this is our little team right here. Me and Kit Quitmeyer run a little makerspace here in Panama, and we have two PhD students we're supervising, Bree Johns, who's now in Melbourne, Australia, and Hubert Stigl, who's starting his PhD in Sweden. And I'm kind of a designer, hacker, even got tricked into starring in a weird TV show for a little bit. But me and my partner run a little place called Digital Naturalism Laboratories, which is kind of a maker space for doing art and technology for interacting with nature. We try to do as much as we can about putting this technology actually in the wild. So we're based here in Panama, right on the Panama Canal. This is our little town called Gamboa. And so Dynalab is our little solar-powered prototyping facility, workshop. We got laser cutters, 3D printers. We also do a lot of our own upcycling here and do like upcycled printing of stuff. We help run a bunch of different cool art and science events, teach field courses, design courses with universities all over the world. We also run our own conferences, such as the Digital Naturalism Conference, which is really cool. We just finished up the one in Indonesia this past summer. We'll probably have another one in 2 years. And basically, we usually get 100, 200 artists, scientists, designers, field biologists all together to kind of work and live in a really interesting natural place to build tools for interacting with nature. We also work with the Gathering for Open Science Hardware. If you haven't heard of GOSH, it's a really cool community of people in doing institutional science and engineering and design, as well as people who are non-institutional, kind of like me, who are doing science, engineering, and design with the goal of making tools that are open. We helped run the GOSH 2022 that was also here in Panama. But kind of the running thread here is that we get field biologists, engineers, artists, and we just try to get everyone interacting with nature in different ways. We do a lot of stuff with rescued animals, animals in the zoo. This is when I taught a course with the Singapore Zoo. This is fun tools for keeping sun bears entertained. That was a red panda puzzle box that my students helped make. We help work with nature reserve animal rescue here. So we make things for the tapir. But kind of the core thing of what we do here is, like I was saying, we make tools for field biologists. A lot of this, we can be hacking existing tools. We can turn regular game camera traps into actually really cheap tools for studying insect behavior, butterfly behavior. With butterflies, the PIR motion detector actually will work on butterflies during the day because their wings change enough IR hitting that sensor. And so we help scientists make really cheap things, hacks and stuff like that to build tools to answer questions. We worked on making 360-degree camera traps for seeing every direction, butterfly strength testing machines. These are floating camera traps for studying fishing bats that also have to be disguised as garbage, or else they kind of get stolen when they're floating around in the river. And kind of one of the most important things for us is that every single thing we do is open source. So we appreciate amazing tools like FiftyOne that are open source. And the reason behind that is because if it's not open, you can't actually do science with closed tools. It's not how it works. The core is it needs to be replicable. It needs to be accessible. It needs to be equitable. And if you're not doing that, you're not really doing science. So that brings us to the thing that we're working on the most for the past 2 years now is this thing called the MothBox. It's certified open source hardware. If you're working on any kind of hardware things at all, I highly recommend check out the Open Source Hardware Association. They have a really cool certification process where they will help share your cool projects around the world, and also help build up prior art and submit them to like patent databases so somebody can't try to patent your thing that you actually open source. Cool organization. A bit of a background on our project here. So the way this whole project started, it starts with Panama. So this is where we're at. It's a very skinny country, maybe one of the skinniest countries in the world. And there's this little chunk that kind of sticks out the bottom there. That chunk is called the Azuero Peninsula. And what happened is this Azuero Peninsula is a really cool, it's got cloud forest, it's got jungle and stuff like that. So beautiful rainforest everywhere until pretty much colonization happens, especially in the 1940s with the American colonization during the war. There's massive deforestation. Americans were there and they go, hey, we want hamburgers, chop down all this forest. So before we had forest, now there's beef. And this has been very environmentally horrible for the whole region. The beef farmers, as well as the animals there, the beef farmers can't actually even get loans from the bank anymore like they could maybe even a decade or two ago because the soil is so degraded. The climate's literally changed over this entire peninsula, that they can't grow grass there for cows anymore. It's a dry, arid place. It feels almost like California while you're there, where it used to be literal rainforest. So a lot of people go, oh, just reforest. We need to plant trees. That's the solution, right? One thing I would like to just impress on everyone that I meet: we as humans don't actually know how to recreate healthy ecosystems. We can destroy them. We can plant trees in places, but generally what happens is we plant what they kind of call dead forests. There's no biodiversity in these places. So my friends who are doing a big reforestation project, some scientists, they did a survey. Reforestation projects around the world, 90% of them don't actually plant native trees of many species. Most places plant just single monocultures and generally of non-native species. So here in Panama, you'll see massive teak plantations. They're monocultures. They're non-native trees. It's not actually reforesting. It's not actually bringing back the ecosystem there because the local animals don't know how to interact with this. It doesn't actually help them out. And in fact, it butts out a lot of the original creatures. So native creatures don't actually like it here, but this kind of thing can be used for a lot of greenwashing. And in fact, you can get residency in Panama by paying like $50K to reforest a part of Panama that gives you a 30-year tree farm that then gets chopped down in 30 years and turned into furniture. Anyway, so main point, we don't yet know how to recreate healthy ecosystems, but there's scientists who are starting to look, how can we actually reforest? And these scientists want to study biodiversity. This is kind of the key metric. It's one word, can be easy to say, oh, there's more biodiversity, oh, there's less biodiversity, but actually it's an incredibly complicated topic. But if we can boil this concept down, you can think of it as like, okay, you had primary forest, and let's say you saw 98 monkeys, but you saw 5 different species. Then you have a farmland that's been chopped down, burnt up, no monkeys seen there. Then you restore the forest, you plant some trees there. Oh, and you see, oh, okay, cool, we got 15 monkeys we saw on the farm, but only like 1 species. So you can try to see like differences in biodiversity using monkeys as a sensor, right? You'd be like, okay, well, 5 is more than 0, so that's not good. But 1 is more than 0, so maybe it's coming back. But this is a very blunt sensor. Using monkeys as your sensor, it's not that great. And so there's groups trying to figure out, how can we actually reforest? How can we bring the forest back? How can we restore the biodiversity? And this brings us to maybe we should look at moths. Moths, okay. Why moths though? So most ways that scientists have been studying biodiversity have been looking at birds and mammals. Birds and mammals, terrestrial species worldwide. That's basically what people tend to look at and think about when they think of biodiversity. The problem is, though, if you look at all the different species, that's only about 6% of the species. 94% of these kind of terrestrial creatures are actually insects. So insects are hyper diverse. If you think about everything that scientists have ever given a name to, like every fungi, every animal, every plant, every single celled amoeba. We've done this about 2 million times. There's about 2 million species we've listed. 1 million of those are insects. Insects are amazingly hyper diverse. So 1 out of every 2 creatures you might pull out of a bag is an insect. What's more, 1 in every 5 species, again, of all known species on Earth is a beetle. 1 in every, this is actually updated, 1 every 10 is a moth, which is wild. So you can think about, of all the mammals, there's only 6,500 mammals. There's only 18,000 species of birds about. That's 1 in every, 100, 1 in every 300. If we think about trying to use monkeys, for instance, as our sensor, we can have like, okay, it goes from 0 to 1. That's a very low resolution sensor. If we think about trying to use insects as a sensor, we can be like, oh, over here we saw 1,500 different species of insects in this part of Panama, but that wasn't chopped down. Then we saw 9 species in this farmland. Then we saw 206 species. You get this idea. You have a really robust kind of sensor that you can use. The other cool thing about insects is they're hyper localized. Some species are even endemic to small areas. So, if you've seen this, it's definitely from around that. Some caterpillars are even host specific. So, if you've seen this type of insect within a couple 100 meters, you'll know what type of plant is also present. In comparison, if you're just studying something like mammals, like we do in traditional biodiversity surveys, mammals might cross large areas. This monkey probably doesn't live in this burnt out patch of farmland that we got on this camera trap. It's probably just moving, and they can move kilometers and kilometers. The other cool thing about insects, they're easy to attract. Long ago, we figured out how to jam their navigation with light. Monkeys don't really respond to our black light, but it's still really, really hard. You need trained PhDs to stay up all night, look at all the insects, write down every insect that's visiting. It's not a solution that's scalable. And you might have thousands upon thousands of insects visit a single light trap during a night. So 2 years ago, we saw this cool paper where some scientists were trying to use basic Raspberry Pi camera setup to try to automatically detect insects this way. So we tried, I talked to my friends who do biodiversity monitoring, and they're like, hey, let's get one of those. And so we looked into it, but the systems are expensive. It's like 9 to 15K. There can be little documentation, they can be closed source, generally kind of lower resolution. And these things can be large and heavy. Usually they're designed for being installed in one specific place. And usually a place that has power, not places like we're going in Panama, where we're trying to survey vast mountains and hills in places that, many humans haven't been to in months or sometimes even years. It can be that difficult to get to. So we decided, hey, let's build our own. So we started iterating and iterating. And importantly, we iterate in the field, because every time you have a piece of technology and you bring it to the field, the first thing that's going to happen is it's going to break and fall apart in many different ways. The other really important thing as any kind of designer is we need to do iterations with local communities. We need to do this stuff with the people who are actually going to be using these things. Because it doesn't matter how you design a switch or a button, as soon as you give it to somebody else, they're going to find amazing ways to move that switch or button in ways you didn't expect. So it really helps break your assumptions. And this is the reason we kind of design and build and iterate in the field. Because like I said, digital technology works amazing in the lab, but tends to fail in the wild. So in terms of hardware, this is, I can kind of go over this. You seem a bit more software-y types, but it's kind of fun to think about. We try to make this whole thing, there's no soldering. It can all be field repairable with just a hot glue stick, a razor, and a lighter. You can fix this whole thing up in the field. Many of the field parts are redundant. How do you use this thing? You hang it on a tree, you leave it, it just automatically runs on a little timer built in. On the Raspberry Pi 5 has a built-in real-time clock. It runs automatically. You download the photos, and then you start processing the photos. And this is where we get to stuff that I feel like this audience is much more interested in. We want to process all of these photos. So we have big photos that look like this, where there's many different creatures. We then break them down into 51 turns into little patches. And then we run some open source models on them that we've trained to not only detect the creatures, but then also try to ID them. We use a PyBioClip V2 is what we've been doing that. But importantly, this is where a lot of other systems kind of stop. They go, oh, hey, the computers did stuff, our job's done. No, we don't trust the computers in the field. We can use them to organize stuff. We don't trust them. And so we use basically FiftyOne to be a UI where we set up a little basic user interface where then the scientists can actually look through all of this organized data, validate if it was actually, this is actually Lepidoptera, or maybe it thinks for some reason this one moth was a beetle. They can quickly check this, and they can process an entire day or an entire night's data set in just a couple minutes versus having to sit at one spot for an entire night. So this data can be output into things like Darwin Core. This is what a lot of the scientists use as a standard for sharing biodiversity data, but you can also do fun visuals with it. So I've made lots of open source scripts to take this kind of rich data and turn it into fun, cool visualizations. We even do a fundraiser where we sell like cool moth fashion. The device that we're using right now, it uses a really high resolution 64 megapixel camera. This is because we're interested in even Micro-Moths. This is a creature that's less than a millimeter wide that our friend was able to ID to the species level, which is pretty incredible. And you can look at the amount of abundance on one typical image we have going on there. It's important to have this really high resolution, high quality image too, because you need to be able to see these little details when the scientists are making these like ultra refined decisions on what types of creatures these may be. This thing takes multiple power sources. It can be solar powered. You can daisy chain batteries up to it. You can wall power it. It's quite weatherproof. We leave it out in the jungle for sometimes months. You can have multiple target types. And one of the most important things, perhaps, is we made it so it's really small. If you see this big pelican case over here to the left, that's about the size of some of these other insect monitoring solutions that can weigh 50 pounds and be really heavy. And instead, we're trying to make ours small and light for field biologists to go into the forest, set up, toss, I can carry 3 to 6 in my backpack, set them up in the forest, leave them for several days or weeks, and then come back and get all the data. We've had deployments all around the world at this point. The small size even lets us do like amphibious deployments, places a lot of other tools can't really reach. And one of our biggest expeditions, we surveyed an entire cloud forest mountain here in Panama. We had 19 of these moth boxes simultaneously surveying a gradient, an elevation gradient. And so you can start getting really cool data where you can see at the exact same moment, what does a photo, what does, a picture of the biodiversity look like as you change an elevation across this mountain. So this is like cool data that nobody's ever been able to really see before. Everything's open source. You can build your own. There's multiple fabrication options. Even kids have built them in libraries. And the future is we were super lucky to have just gotten a grant from wildlabs.net. This is another amazing resource if you don't know about it. Wildlabs.net is a kind of conservation network where there's lots of cool conservation people and engineers all working on, kind of wilderness technology. So it's a great place for everyone to go to check out all kinds of cool projects. And they even have a grant program once a year. We've been lucky enough, we've won it the past 2 years in a row. And they've supported us to actually bring this to the next version of the MothBox that's going to be Mass-Manufacturable. And so we're working on this right now. We have multiple prototypes hanging out with us. It'll drop the cost of building one of these things yourself about $100 to be about $300 in parts for one of these moth boxes. And we're doing lots of other different cool projects. We're also thankfully sponsored by the American Museum of Natural History, also helped us sponsor to build this project. And yeah, so our current timeline is we're hoping to have these things available for distribution in probably January. Yeah, so we're building that. Things are going quite good. And yeah, we're post-processing data right now. And if you have questions or anything, please feel free to reach out to me. If you're interested in the MothBox, we have a mailing list where we talk about the developments and updates of the MothBox projects. And yeah, I think that's pretty good for me.
Fantastic. So if you are interested in learning more about the MothBox project, I have included a link in the chat there. If you have any closing questions for Andrew, make sure to drop those either in the chat or in the Q&A. So while you're thinking up your questions, a quick review of some of the housekeeping items is all the talks are being recorded. We will upload them to YouTube. And if you want to get notified as soon as those playbacks are live, make sure to subscribe to the Vox 51 YouTube channel. We'll also be including all the links, not just from Andrew's talk, but the other speakers as well, research papers, GitHub repos, etc. We'll gather all those up and drop them in a summary email in your inbox. Look for that probably late morning to early afternoon tomorrow. And of course, this is day one of 2 days of virtual events that we're having around the intersection of visual AI and agriculture. Make sure to go to the events calendar. There's also a workshop that Paula will be doing in 2 weeks. Plus, there's also 2 in-person events if you're in the Raleigh area or if you are in the Ames, Iowa area. Both of those events are going to have a heavy agriculture theme. So if you're in those locales, check out the events calendar and register for those events as well. Question. How do you envision using the MothBox findings to improve tangibly biodiversity? More funding, academia push, or is the soil the limit? Smiley face.
I like that. It's kind of it's everything. It's a really cool new frontier of science is this kind of insect monitoring. People have been doing this kind of research for the past 100 years, at least. So there's systems and ways that people in conservation spaces, in agriculture spaces, in purely scientific spaces have been looking at trying to study like insect biodiversity. But until the past couple of years, it's been very limited as the scope that we can do. The goal here is basically expand this whole playground to make it much, much bigger so that you can actually start doing this stuff instead of like a long-term survey at like 5 points over the past 50 years, which we have like some of these things when you hear about like, oh, there's insect decline, insects have declined 75% in Europe, that kind of thing. Those come from very limited sites where they're not even really able to tell the species apart. They literally are studying abundance. They have jars that all the bugs go into, fill up a jar, and they weigh the jars. And so this is basically like opening a whole new lens on this same type of research. So I think it'll impact all these different areas. It's kind of like going from like, you know, old-fashioned telescopes to having like a Hubble telescope. This kind of broadening of stuff. One thing I wanted to mention real quick about FiftyOne is one of the reasons that we started using it for post-processing is because field biologists tend to have a limitation where we can't necessarily rely on cloud computing or uploading all of our data to like big servers. For instance, something like that mountain that we traversed, that's 500 gigs of data we're getting over the course of like 3 nights. And so a lot of times we don't have access to going on the internet and processing all this stuff, like with a lot of machine learning stuff gets done these days. And a lot of us don't even have money to access like a supercomputer cluster or something like that. So everything, all our scripts are all run locally. And the reason that we went with FiftyOne is because it gave us a local option to actually sort and use this data locally. And that was really key because I've seen other ways of dealing with machine learning data, but you have to get all of your data into some cloud thing with an account first. And that's a real limiting factor to really making a broader impact, I've noticed.